All right, so in this video, we're going to be graphing quadratics in the intercept form. So the intercept form of a quadratic is y is equal to a times x minus p times x minus q. And before we move on to graphing some examples, let's first break down what the value of p stands for and what the value of q stands for. And just to break that down, let's get the x-intercepts of this quadratic because the intercept form is called the intercept form because we can get the x-intercepts of the quadratic in that form and then graph it from there. So to get the x-intercepts of any graph, you want to plug in a 0 for the y value. And upon doing that for the intercept form of a parabola, we have 0 is equivalent to a times x minus p times x minus q. And if we solve this equation for x by the zero product property, so either this factor or that factor has to be a 0 for the entire product to be a 0 at the end. So either x minus p would be equivalent to 0, or we have x minus q would be equivalent to 0. And upon solving both of these individual equations, upon adding by p for the first equation, x would be equivalent to p, and that would be the first x-intercept for our quadratic. And upon adding by q on this for the second equation, then x2, the second x-intercept, would be equivalent to q. And what this tells us is a very important piece of information, that the p and the q are nothing more than just x-intercepts of the quadratic function. So let's put that here. The p and the q values are x-intercepts of the parabola. All right, so the graph is based off of the p and the q values. Now, what happens when you get the p and the q values? Well, to graph a parabola, we need to locate where the vertex is. So let's just say that the p value is a -3 and the q value is a positive 5 for some quadratic function. And let's just graph that out. So if p, which is your first x-intercept, is a -3, which is right over, that's -1, 2, and 3. And let's just say that q is a positive 5, so 1, 2, 3, 4, 5. Then where would the vertex be? Well, whether the graph is upwards facing or downwards facing, whatever the case may be, let's first graph our parabolic curve. And it should look something like that. And notice how everything would be symmetric. So this x-intercept of p, which is -3, would be symmetric with that x-intercept of positive 5. And if they're symmetric about the x value of the vertex. And that is called the axis of symmetry. So the axis of symmetry seems to be right over here. And what the p and the q tell you is a very important piece of information. It tells you what the x value would be for the vertex. And the vertex is right over here. So the x value for the vertex would be simply just the average of the two x-intercepts of the quadratic function. So to get this x value, we can take the midpoint between -3, which is our p, and positive 5, which is our q. And the midpoint would be their average. So we take -3 plus 5 and divide that by 2. And that gives us a positive 2 divided by 2, and that would be a 1. And then from there, getting the y value would be pretty easy. You plug in a 1 for the value of x for every x in the original function, and you solve for the value of y, and that would give you what the vertex is. And 3 values would be sufficient for you to graph a parabola, and that's pretty much what the template would be to graph a parabola in intercept form. All right, so now that we know what the p and the q stands for and how to get the vertex given the intercept form, let's apply this into some practice. So we're given for number 1, to graph the quadratic function, y is equivalent to 1/2 times x minus 1 times x plus 7. All right, so again, this is in the form of y is equal to a times x minus p times x minus q, where we know that a would be a 1/2, and then p would be a 1, and q would actually be a -7, which why would it be a -7? Well, we don't have an x minus 7 over here, so to to put this in the proper form of the parabola in the intercept form, we can rewrite this as 1/2 times x minus 1. This is already in the form of x minus p, and then to put this in the form of x minus q, well, we can make this into x minus the quantity of -7. All right, because we still maintain the value. Negative and negative does give you an overall positive symbol, but we broke it up in such a way that we can write this as a factor in the form of x minus q, where the q would be a -7. Now everything lines up. We know that the a value is a 1/2, the p value is a 1, and the q value is simply just a -7. So once we know all these numbers, well, we just found out in the previous step that the average of the two x-intercepts would be the x value for the vertex. So if you graph this out, let's first make the coordinate plane. So we know what the two x-intercepts are, which we have a positive 1. The value of p is a 1, and the value of q would be a -7. And so these are the two x-intercepts of our quadratic. And if you want to think of it as the x-intercept process way, then if you solve for the x-intercepts manually, then that would be 0 is equivalent to 1/2 times a quantity of x minus 1 times x plus 7. So we already know what the value of p and q is, but if you want to get it using the zero product property, it's the same idea. So you would set both of your factors equal to 0, and we can see that upon setting x plus 7 and x minus 1 equal to 0, that x would be either a positive 1, and that would be the p value, and then or x would be a -7, and that would be the q value. Right? So either we do it using this process or using this process, we end up with the same two x-intercepts, and those are the p and the q values. So let's just graph the positive 1 right here. That's our first x-intercept, and then we also have a -7, which -1, 2, 3, 4, 5, 6, 7. All right, so we know what the two x-intercepts are. Now let's go on ahead to finding the x value for the vertex, which would be the midpoint of the two x-intercepts. So again, to get the x value of the vertex, I'll put the work here for that. You want to get the average between 1 and -7, so it should be the sum of 1 and -7 divided by 2 to get their midpoint. And 1 plus -7, well, that would be a -6. And -6 divided by 2 gives us a -3. So we know that the x value for the vertex would be a -3. Once we know what the value of x is for the vertex, to get the y value, you plug it back in for every x in the original function, which is right over here, right? So we can plug in for the value of x a -3. So we have 1/2 of the quantity of -3 minus 1 times -3 plus 7. And that gives us a 1/2 of the quantity of 3 minus 1 would be, or -3 minus 1 would be a -4. And then -3 plus 7 would be a +4. And 4 times -4 would be a -16. And 1/2 of that would be a -8. So we know that the vertex would be located at, when x is a -3, then y would be a -8. So 3 points are sufficient for us to graph the parabola. So we have -3, -1, 2, 3, 4, 5, 6, 7, 8, and that would be approximately over here. And of course the a term is positive, so it's an upwards facing parabola. And that makes sense if you connect the 3 points. And our parabolic curve looks something like this. All right, so that's number 1. Now, whether you get the p and the q value using the first formation, which is right here, or if you want to use the second form, which is the zero product property, both ways are fine. Whichever way you find more comfortable would be the way that you should be using. All right, so let's go over one more example. So we're given for number 2. Graph y is equivalent to -2 times the quantity of x plus 1 times x minus 3. All right, so now to get the x-intercepts of this quadratic, or the p and the q, let's use for this the zero product property. So we can set the entire function equal to 0, and either x plus 1 would be equivalent to 0, or x minus 3 would be equivalent to 0, and that gives us an x value of negative 1, and the other one would be, if you add 3, the next would be a positive 3. And these would be the value of p and q. P would be a negative 1, and q would be a positive 3. All right, so once we get these, then we know graphically that the midpoint between the two x-intercepts would give us the x value for the vertex, right? So that's step 1. Now for step 2, again, let's get the x value of the vertex. So the x value for the and let's put that down over here. The vertex is x value, and that would be simply just the midpoint between the two x-intercepts, which is negative 1 plus 3 divided by 2. And that gives us a 2 divided by 2, which gives us a 1. All right, so now, and then step 3 would be to get the y value of the vertex. And that would be, you plug in for the value of x in the original function, a 1, right? So that's negative 2 times the quantity of 1 plus 1 times 1 minus 3. And that gives us a negative 2 times 2. And then 1 minus 3 would be a negative 2. Which negative times negative gives us an overall positive. And 2 times 2 would be a 4. And 4 times 2 gives you an 8. So we know that the vertex would be located at the point 1, 8, which would be a combination of steps 2 and 3. All right, so, and now once we have the vertex and the two x-intercepts, that would be enough for us to graph our parabola. So let's graph everything on a coordinate plane. So we know that 1, 8 would be where the vertex is located. And so that's 1, and that's 1, 2, 3, 4, 5, 6, 7, 8. Which is right there. And then we know that the first x-intercept, the p value, was a negative 1. And the value of q was a positive 3. So that's 1, 2, 3. And upon connecting all 3 points in a parabolic curve, that would be the graph of our parabola. All right, so one last example. We're given for number 3 to graph y is equivalent to 3 times the quantity of x plus 4 times x minus 2. All right, so again, using the zero product property, if you set the entire function equal to 0 to get the x-intercepts, then either x plus 4 should be equivalent to 0, or we have an x minus 2 would be equivalent to 0. And in the first case, x1 should be a negative 4. And in the second case, x2 should be a positive 2. All right, so that would be step 1. You want to get the x-intercepts of the quadratic, which are the p and the q values. Once we get those, you then want to move on to step 2, which we know that the midpoint between the two x-intercepts gives us the x value of the vertex. So the vertex is x value, which let's put this down, x comma y. That x would be the midpoint between negative 4 and positive 2. So let's get the average. We have negative 4 plus 2 divided by 2. And negative 4 plus 2 would be a negative 2. Divided by 2 gives us a negative 1. And once we know what the value of x is, let's plug it in for every x in the original function in step 3 to get the value of y for the vertex. So y would be equivalent to 3 times negative 1 plus 4 times negative 1 minus 2. And that gives us a 3 times negative 1 plus 4 would be a 3, and negative 1 minus 2 would be a negative 3. And it's an overall negative symbol, and 3 times 3 times 3 would be a 27. All right, so we now know what the value of x and y would be for the vertex. It's at negative 1, negative 27. So if we graph this on the coordinate plane, so we have negative 1 would be the x value for the vertex. And again, that's the average of the two x values, negative 4 plus 2 divided by 2. And we got -1 for that, so we plugged it back in for every value of x in the original function. Okay, so -27, so that's -1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. And that would be at the very bottom. It's way off the chart because it's a very big negative number. And the two x-intercepts were -4, so -2, 3, 4, and +2. So it's a pretty narrow curve, and the vertex is all the way at the bottom. And that makes sense because the a term is a 3, so the curve gets more and more narrow. And the scale is a bit off, but it's a pretty narrow graph, and the graph would look something like this.